Hi, my name is Kasher Razavi. Today I'm going to talk about the benefits of radioactive isotopes. In this presentation, I'll be first talking about what are isotopes and what are radioactive ones. Secondly, we'll be looking at the benefits and usages it has in medicine. Lastly, we'll be talking about its industrial usages. The sources which I used for this project were an article named Towards Body-Friendly Cancer Treatment by Janet Ruffle, which I found by using SRIs, and my other sources were World Nuclear Association website and the United States Department of Agriculture. Isotopes. As we all know, many elements have isotopes, are elements with the same number of protons or atomic number but with different masses due to the number of neutrons. As a result, the mass number of the element changes. There are 82 stable elements and about 275 stable isotopes of these elements. Radioactive isotopes. When a combination of neutron and protons, which does not already exist in nature, is produced artificially, the atom will be unstable, and this is called a radioactive isotope or radioisotope. But there are also natural radioisotopes which arise from the decay of uranium and thorium. Overall, there are some 1,800 radioisotopes. At present, there are up to 200 radioisotopes used on a regular basis. Most must be produced artificially. The nucleus of a radioisotope usually becomes stable by emitting an alpha and or beta particle. These particles may be accompanied by the emission of energy in the form of electromagnetic radiation, known as gamma rays. The particles which are emitted by the isotopes are used in medicine and also have industrial usages too. Alpha particles are the weakest particles and gamma rays are the strongest. Isotopes and medicine. The technology of medicine is developing rapidly in such ways that diagnosing a disease has become less painful and easier. One of these improvements in medicine is the use of nuclear medicine. Nuclear medicine is a branch of medicine that uses radiation to provide information about the functioning of a person's specific organs or to treat disease. In most cases, the information is used by physicians to make a quick, accurate diagnosis of the patient's illness. It has made examining and diagnosing patients easier and more exact. It is also used to control and treat cancer. In the US, there are some 18 million nuclear medicine producers per year among 305 million people, and in Europe about 10 million among 500 million people. In Australia, there are about 56,000 per year among 21 million people, all of these using reactor isotopes. The use of radiopharmaceuticals in diagnosis is growing at over 10% per year. Nuclear treatments. Rapidly dividing cells are particularly sensitive to damage by radiation. For this reason, some cancerous growths can be controlled or eliminated by irradiating the area containing the growth. By using the rays that a radioactive isotope emits, physicians target cancer cells and kill them in the tissue by minimizing the harm to normal tissues. These rays, which are alpha and beta, can be ranged short distance in tissue, typically 5 millimeters or less for betas and less than 1,000 that distance for alphas. Using these particles, there is a far less risk than with X-rays that these types of radiation will spill over to cancer-free tissue. Also, another treatment is external radiation procedure, which is known as the gamma knife radiosurgery, and involves focusing gamma radiation from 201 sources of cobalt-60 sources on a precise area of the brain with a cancerous tumor. This new technology has helped many people around the world. Another benefit of radioactive isotope treatments is the waste that is produced after the treatments are done. When radiography sources have decayed to a point where they are no longer emitting enough penetrating radiation for use in treatments, they are considered as radioactive waste. These wastes aren't high-level radioactive wastes. They include paper, rags, tools, clothing, and filters, which contain small amounts of mostly short-lived radioactivity. These types of waste often undergo decay storage for periods of months to a few years before being disposed of at urban landfill sites. Radioisotopes also have industrial usages too. They are used in medical sterilization, food preservation, tracers, and gagging, and household smoke detectors. Sterilization. Gamma rays are very penetrating and commonly used for sterilization of disposable medical equipment such as syringes, needles, and IV sets. This is usually done by cobalt-60, which continuously emits gamma rays. Another industrial use of radioisotopes is food irradiation. Food irradiation is a process in which approved foods are exposed to radiant energy, including gamma rays, electron beams, and X-rays. In 1963, the Food and Drug Administration, FDA, found the irradiation of food to be safe. The sources and amount of energy that can be applied to foods are not strong enough to cause food to become radioactive. And also, scientific studies show that food irradiation does not significantly change the nutrient content, flavor, or texture of food. Tracers and gagging. The ability to measure radioactivity in minute amounts has given radioisotopes a wide range of applications in industry as tracers. By adding small amounts of radioactivity substances to materials used in various processes, it is possible to study the mixing and flow rates of a wide range of materials, including liquids, powders, and gases, and to locate leaks. Tracer technologies have been used in plant operations to check the performance of equipment and improve its efficiency, resulting in savings in energy and the better use of raw materials. Gags containing radioactive sources are in wide use in all industries where levels of gases, liquids, and solid must be checked. These gags are most useful where heat, pressure, or corrosive substances such as molten glass or molten metal make it impossible or difficult to use direct contact gags. Radioisotope instruments have three great advantages. Measurements can be made without physical contact with the material or product being measured. Very little maintenance of the isotope source is necessary. The cost-benefit ratio is excellent. Smoke detectors. The use of Americum-241, which is a radioisotope, is known for household smoke detectors. AM-241 emits alpha particles and low-energy gamma rays. The alpha particles emitted by the AM-241 collide with the oxygen and nitrogen in air in the detector's ionization chamber to produce charged particles, which are called ions. A low-level electric voltage applied across the chamber is used to collect these ions, causing a steady and small electric current to flow between two electrodes. When smoke enters the space between the electrodes, the smoke particles attached to the charged ions neutralizes them. This causes the number of ions present and therefore the electric current to fall, which sets off an alarm. Canada and radioisotopes. The National Research Universal has been at the center of Canadian research for 50 years. It has supported fundamental research in materials engineering, physics, chemistry, and biology. The NRC's Canadian neutron beam Center has also established Canada as a worldwide leader in providing access to industry from key sectors nuclear, aerospace, automotive, and manufacturing. The unique knowledge obtained using neutron beams helps companies to develop more competitive products that are safer and more reliable and less expensive to manufacture. In overall view, we will see how radioisotopes have improved our lives significantly by making it easier and safer. Radioactivity isotopes studies have also helped us in many fields of studies such as chemistry, physics, and even biology. Thank you for your attention.